Hello. You should see the desktop and you should hear me by now. There's still a lot of people to come in. Okay. Is everything okay? Can you hear me? See the desktop? I got my speaker on. Everything seem okay? Is anybody, can you hear me?
Yeah.
Okay. Yeah, great. Okay. All right. Looks like most people have arrived. Takes a little while for them to be let in. Okay. There's a bunch of things to bring up that are new up on the website. So your homework assignment's been up there for a while, but we'll go over it. So we'll talk about the new programming assignment because it's very much a review of what we've been talking about for last week. So it's not a hard programming assignment. It just makes you uh, study all the ideas that we've been talking about for the last week. Okay, then the final. This is the last week of the semester. So the final exam, according to the university, has a final exam schedule that they put up. Professors don't decide when the final exam are. So this is what the schedule looks like. Okay, and the way the schedule works is you look up what day of the week your class begins with. Like our class begins on a Monday at 12:30. So here's Monday, Wednesday, Monday, Wednesday. Here is classes that begin on Monday or Wednesday between 12 and 1. So our final exam is Monday. Okay. So you look up in the schedule when the final exam, and you can look up all your courses in here. So we'll have the final exam on Monday. Notice that that's our regular class time. Your final exams don't even have to be at the regular class time. If you've got if you had a class that was meeting in person, this would be actually more important. But in our case, the exam will be just like the previous two exams. So I'll make the exam available at that time, and then you'll have till midnight to turn it in. So we'll do it real similarly to the way we did the previous two exams, but we won't meet that day for class. So the exam will just be available at that time, and I'll be available for answering questions. Okay, so it says here, the exam will be at 12:30, and what we'll do is the exam will just be available on Brightspace, and you can download it and take the exam. But I'll be in like a Zoom meeting during the class time, and then you could ask me questions in the Zoom meeting if you want to, or you could send me email and ask questions. So the exam will be very much like the last two exams were. Okay, and then we've covered the exam is over the whole semester. So you need to look at the exam 1 review and the exam 2 review and your exams. You have access to your exams on Brightspace. So you should make sure you can solve all the problems on your exams. I think you should download your exams from Brightspace, your exam 1 and exam 2. If anybody has trouble downloading, you should be able to download them. You're supposed to be able to read them and you should be able to save them. If you have any kind of problem, let me know. But you definitely want to get those because that's one of the things you should study. You should be able to do all the problems on those two exams. So look at these reviews for exam 1 and exam 2, okay? And also download your copy of exam 1 and copy of exam 2 and make sure you understand what you did right and what you did wrong, and ask questions if you have questions about how things were graded, how things were supposed to be done. And then here's a review for problems we've done, for what we've done since the second exam. We've covered arrays and classes. We've covered 2 topics, arrays and classes. They were spread over these chapters in one book, and they were spread over these 2 chapters in the other book. So these are the specific sections that we covered, and these are the ideas of what we covered: arrays, references, objects, array objects. Okay. So, and then, like before, here's a list of problems. These problems are only about these topics, okay? So there's a list of problems here about these topics, and you should also review the previous 2 review sheets and your 2 exams for making sure that you understand what we did before, okay? So these are review problems for what we've done since the last exam, and we can go over these on Wednesday. So if there's questions about these problems, we can spend Wednesday talking about these, looking at examples of these problems. the first half, there's about half of them are about arrays, and about half of them are about classes. Okay. All right. So the final exam will be a week from today. Oh, and remind you that according to the syllabus, you know, the final exam is 20% of your grade, which is a little bit more than what the midterms were. The midterms were 15% each. So the final exam is a little bit longer and worth a little bit more than your midterm exams were. So instead of being about 9 problems, I think the midterms were 9 problems. This might be 11 or 12 problems. So the final exam will be a bit longer. It's worth a little bit more. Okay, right? So that's the weight that the exam is worth that much of your grade. Okay. Now let's see what else. Anybody have any question about the exam coming up? It's a week from today. Anybody have a question about the exam coming up?
Will we be able to, like, you know how, like, a day or two before, like, the exam, well, I guess you would say Wednesday, will we be able to go over Wednesday about, like, questions on the final exam
Well, yeah, that's
or
like,
the final exam review?
yeah, that's what, I just said that a second ago. That's what I meant. Yeah, this review we can do on Wednesday. We can over here. Here, these review problems. If we have questions about them, we can look at them on Wednesday.
Okay,
Definitely.
thank you.
Yeah, we can spend Wednesday going over these review problems. Okay. So try to look at them and see if you have a quick question about them before meeting a class on Wednesday. And if nobody has any questions, we'll just do a couple. Yeah, but we'll work on these on Wednesday. Okay. And also they're review problems. So as I've said before with the other reviews, if you have questions about, I'm not going to give you answers. Like I just like with the last two, I won't post solutions to all of them, but I'll answer questions about any of them. Okay, so I'll tell you if you did them right or wrong. I'll tell you if you show me your answer, I'll tell you if it's right or wrong. You can ask me questions about them. Okay, so okay,
We
and
have a question in the chat, Professor.
yeah, no, I can't change that. The university policy is that if it's in the syllabus, I have to go by what's in the syllabus. Yeah. See, that would be, that'd be an interesting suggestion, but that would be something I'd have to, the university policy is that I have to go by what's in the syllabus. If I change the grading scale now, it's like changing the rules in the middle of the game, because the grading scale was given to you at the beginning of the semester, and so the grading scale will stay that way. Okay, so I'm not supposed to change it after. I mean, that's an interesting suggestion. I've never thought about that one. Okay. No, but no, but I can't, but I can't change it now. Okay. Okay. So if you have questions about your grade, send me an email. If you have questions about how you've done in the past, please send me emails and things like that. Okay. So, all right. Now, let's see. Okay. Other questions about the exam coming up? Other questions about, there'll be plenty of time on Wednesday. Specific questions about problems we'll do on Wednesday. But anybody have a question about the mechanics of the exam? What's coming up? Okay.
What would you say, like, the rough estimate of how many questions we're going to have?
About 11 or 12.
Okay.
Your midterm exams were 9 questions each, if I remember right, and this exam's worth a little bit more, so it'll be a little bit longer. So maybe
I
like
mean, yeah, roughly the final exams we have, like, what, 2 hours?
actually you've got all day to do it.
Yeah.
Yeah. Because depending on people's schedule, the exam will be available at 12:30 and it'll be due like at 11 o'clock in the evening, like the exams were. Okay, it'll be the same as the exams were. Like it'll be, instead of being available after class like we did the midterms, the exams will be available just at 12:30. They'll become available at 12:30 and they'll be due at 11 o'clock in the evening. So you have pretty much the whole day to work on. If you have to work or if you have anything else to do, you should have plenty of time to do them. Okay. So it'll be a little bit longer than the midterms, like by 1 or 2, like maybe 2 or 3 extra problems long. Okay, and the main thing is it covers everything we've talked about. So you have to be ready for exams, anything from exam 1. You have to be ready for problems like anything from exam 1, 2, or 3. Now, a lot of what was on exam 1 should be pretty easy by now. If you go back and look at exam 1, you may find that we've been doing this stuff long enough that a lot of what's on there is actually much easier now. Okay, so, but you should be prepared for problems from any one of exam 1 or 2 and these new problems, okay? And the new problems that we've, and the new material that we've covered since the second exam, okay? All right. Now there's also, let me open the programming assignment. There's a programming assignment, which is a practice. It's really practice in what we've been talking about this week and what will be on the next exam, classes. Okay, so it's practice in understanding all the ideas for classes. So now it's based on what we did in class last week. We started doing this point class last week. We wrote this in class, what a point object is, with a point that would hold an X and a Y coordinate, okay? So in your homework assignment, there's the point class. It's pretty much this class here. That's given to you in the homework assignment. That's written. You don't have to write it again. And there's also a class called dimension, which represents a width and a height, okay? And then what you have to write is you have to finish this rectangle class and finish this circle class. So these are geometric objects. They represent the idea of a, circle represents the idea of a circle. So it represents a geometric object, which will use a point. So let me open Dr. Java and show you what it looks like, what's there so far. A circle, in object-oriented programming, a class-like circle is supposed to represent what people would think would be the data that describes a circle. So if you think about what a circle is, the main thing is you need to, oh, let's see, it came up. Well, a circle has a center and a radius, but the center is a point, okay? Now let me close Dr. Java and start it back up again because it didn't start up right. Okay, so the circle class is meant to represent what we think a circle would need to know, what we would need to know about a circle. We would need to know its radius, and we'd want to know where it's centered at. But the center has an X and a Y coordinate. We put that in a point object. So the center of the circle is a point object, which holds the X and Y. Now, this could have been written as int X, int Y. This could have been, instead of this, this is my choice as the person designing the class, I could have said, instead of putting the coordinates in a point, I could have put the coordinates right here in the circle. But I decided to do it this other way instead. So this is a matter of choice. The person designing the class gets to choose how they do things. Okay, so a circle definitely needs a center and a radius. And the center, here it's chosen to be in a point. The data for the center is in a point object. And instead, I could have put the data for the center right there. Okay, now, if you look at the description of the homework, you have to finish this. See, there's not much here right now. And if you look at the homework assignment, it describes what you're supposed to put into each of these classes. Like, for example, the rectangle class. Let me just open the rectangle. A rectangle is something like a circle. You need to know where it is and how big it is. Okay, so this tells you how big the rectangle is, how wide and how high it is. And this tells you where its upper left-hand corner is. So this is actually the upper kind of instead of saying what the center of the rectangle is, this is the way a lot of libraries do it this way. A lot of Java programming libraries do it this way. Circles have a center, but a rectangle has an upper left-hand corner. Okay? A rectangle also has a rectangle also has, I'm sorry, a rectangle also has a center, but instead of recording where the center of the rectangle is, it's real common to record where the upper left-hand corner is. And notice I didn't put it in a point. I could have made this one could have done it like this. Make the point the upper left-hand corner. But I chose instead to do it where the rectangle records the X and Y of its upper left-hand corner, but the circle stores a point for its center. Okay. All right. So this is what you're given is what the core data is in the class. So you're given that circle has a point that's a center and a radius, and you're given that rectangle has an upper left-hand corner and a width and a height. Okay. And then you have to fill out most of the rest. Like now, in case of the rectangle, I put one constructor in there just to give you a sense of, you know, the constructor takes in when it builds the point object, you initialize X, Y, width, and height to be those values. So that's saying, that's building a rectangle object and saying the X in the point in the rectangle object gets that value. The Y in the rectangle object gets that value. Okay. Now in the description here, it tells you what else to put into these. Whoops. In here, it tells you what other methods to add to these classes. Now, you're going to do this in steps. Oh. Okay. Notice that there's here an idea of test step 1, test step 2, test 3, test step 4. You're going to build your circle and rectangle objects in steps. So here's the description of what to do in the first step. Here's the description of what to do in the second step. And then there's the third step and a fourth step. And each step has instructions, and each step has something that tests it, whether you've done whether you're on track so far. So for example, for the first step works on just the rectangle class. You add these methods to the rectangle class. Okay. You add one more constructor, and you add these methods to the rectangle class. After you write those and compile rectangle, then you open this in Dr. Java, and then you'll compile test step 1, run test step 1. The output will appear down here, and the output should look like that. When you run test step 1, you should get that output. Okay, so this will test your rectangle, and this will tell you what the output of the test should look like. Now, when you open test step 1 in Dr. Java, compile it and run it, the output will appear down here. You'll have to compare what's over here with what's down here. Okay, so you have to compare what shows up. Now, I can't run this because it won't compile, because rectangle hasn't been written yet. So since there's stuff missing from rectangle, this test, if I try to compile it right now, see, it complains because there's things missing. Okay, so I can't show you how to run it because there's not rectangle hasn't been finished yet. But when you compile and then now you can't run rectangle because there's no main method in it. So rectangle just describes what rectangles are. Rectangle is not a program. Rectangle is just a class. It doesn't have a main method. So you don't run rectangle and you don't run circle, but you do use them. So the test programs use them. See, the test program creates a rectangle object and calls methods. Well, here it creates a whole bunch more rectangle objects, and here it calls methods on the rectangle. Okay? So it uses rectangle. Okay? So this is the program you can run. See, it's got a main method. So the test programs have main methods. So you would open, do step 1 on rectangle, then open test step 1 in Dr. Java, compile it, run it, and make sure you get that output. Okay. Then you go to the next step. The next step will add methods to the circle class. The second step puts these three constructors in circle and puts these methods in circle. Okay, and then you have to compile circle and run step that you compile circle. Then you can compile test step 2 and make sure you get that output. Okay,
I
and
have
then
a quick question, Professor.
yeah, uh-huh.
So if we could go back to test step 1.
Uh-huh.
So you see on the top, you say do not change this file. So I was working on the first problem, and I wasn't quite able to run it unless I imported the point and the dimensions from.
You shouldn't have to do that. You should not change this file.
I see, but it worked when I actually did that.
But that's because you're doing something wrong in those other 2 files. You're not supposed to
see.
put any package statements in them.
Okay.
You're putting package statements in them, and you shouldn't be. We haven't talked about packages, and packages are adding a layer of complexity that's causing the mistake. So you're adding something that shouldn't be there yet, and it's putting a layer of complexity in there that shouldn't be there. Okay, and what happens if you put a package in there? I have trouble compiling your programs.
I see.
Yeah. Don't put package statements in your classes. That's an advanced topic that we haven't talked about. That packages can make things better and they can make things worse depending on how you use them. Yeah, they're one of the more advanced features of Java. Okay.
So can we run an example then where we're not using the packet, the statements where?
Pardon me?
Can we run something similar then where we can test it?
Just like this. I'm not sure. You just don't put a package statement in your files.
Okay, no problem.
Yeah, they don't need to be there. Java does not require package statements.
Okay.
Yeah, and if you delete them, they actually make things simpler. And then your programs become easier to test and easier to run. The package statements are there for more complex projects. Their use is in more complicated projects. Okay, IDEs tend to put them in there automatically because IDEs assume you're working on a 10,000 line project. But when you're writing simple things like this, the package statements actually get in the way. They cause problems, and so that's why you couldn't compile the test programs. Okay, unless you should not be making changes in here. If you make changes in here, then I won't be able to compile your program and I won't be able to test your program. Okay, so yeah, don't have package statements. Notice there's no package statement in here. See, there's no package statement in here initially. So yeah, don't add package statements, and then you should have no trouble compiling and running these things here. Okay. All right. So the homework assignment steps you through these 4 steps. Step 1 is to add things to rectangle. Step 2 is to add things to circle. Step 3 goes back to rectangle. Step 3 adds 3 more methods to rectangle. And then step 4 adds 3 more methods to circle. And they get a little bit harder as you go along. They get a little bit harder. Like step 1 and step 2 are very simple. Those are the basic steps. And then step 3 and 4 get just a little bit trickier. Now, everything you're going to write is going to be 1 or 2 lines of code. Okay. If you go back to the point class that we did in last week, everything we wrote was just a couple lines of code. Notice that all these methods are very, very short. And if you go over here and you open the point class or the rectangle class that came with the homework assignment, I'm sorry, the point class or the dimension class, you see that they're very short. Notice that there's a 2-line method, a 1-line method, a 1-line method, a 1-line method. This is very typical of object-oriented programming. Lots of very short methods. So for example, point here, 2 lines, 1 line, 1 line, 1 line, 2 lines, 2 lines, 1 line, yeah, and lots of them. This is very typical object-oriented Java programming. This is what a lot of Java code ends up looking like even in the real world. You write lots of short usually 10 lines or less. In the case of these homework assignments, it's usually more like 2 or 3 lines at most. You write lots of very short methods, okay? And the idea is that each short method does one small thing that's useful, okay? So like here, for point, each method does something about changing the method, like you move a point to that location, or you move a point by that much, okay? Or you move a point horizontally, or you move a point vertically. Notice that there's 4 different ways of moving a point because it's just kind of convenient. Sometimes you want to just move horizontally, sometimes you want to move just vertically, sometimes you want to move diagonally, sometimes you want to move to a specific location. So we put lots of simple little move methods in there, okay? And that's very common in object-oriented programming. Lots of little methods that are convenient methods to have in a class, okay? Like this method can find the distance between 2 points, okay? There's this point and that point, and then here's the distance formula out of algebra class, the Pythagorean theorem, okay? The square root of the sum of the squares of the sides. Okay, so as the square root of the sum of the squares of the sides, this is the Pythagorean theorem. It computes the distance between 2 points. Okay, so lots of little methods that do convenient things for you. So the methods you have to write in the homework assignment are pretty much like that. Each one of these methods that tells you to write is usually 1 or 2 lines long. Okay, the ones down here get a little bit harder. These might be 3 or 4 lines long. These might be 3 or 4 lines long, but not more than that. Okay, they're not hard methods. You have to understand what's going on. You have to understand what each one's asking you for, but they're not hard. They're just the main thing they're asking you to do is understand the ideas of practice using the ideas of objects and classes. Okay, all right. Now, oh, let me point out, see, this method here asks if this circle over, you call this method on a circle, okay? Like, look at test step 4. Here, I create 2 circles. Then I ask, does C1 overlap with C2? And I get a Boolean value. Well, what does it mean for 2 circles to overlap? 2 circles of overlap if it has to do with how far their centers are from each other. If the centers are real far apart, they don't overlap. If the centers get close together, they overlap. Well, when do they overlap? When the distance between the centers is less than the sum of the radii, okay? They overlap when the distance between the 2 centers is less than the sum. Like the 2 circles just touch each other when the distance between the centers is the sum of the radii. If you think about drawing 2 circles that just touch each other, where each circle is not inside but outside the other one, then the distance between the centers is equal to the sum of the radii. So overlap needs to check that, okay? But now overlap will need to look at the center of that circle and look at the center of that circle and compute the distance between them. That's where you use point's ability to compute a distance for you. So the point class will know how to compute the distance for you. So you don't actually have to do that. See, if there's enough work spread around these objects, when you have to do something new, like in the center, like in the circle class, compute the overlap between 2 circles, the hardest part of it, finding the distance between 2 points, that's done for you by points. Points know how to measure the distance between themselves. Okay, so when you go to write when you write the overlap, okay, it says here that the point class has a distance method that'll compute the distance between 2 points. So when you write overlap, you make use of distance from the point class. Okay, so these descriptions point out things like that many times when you write one method in an object, you do it by using some other method in the object to help you. So if the objects have been well designed, they have lots of good methods, then the good methods make it easier to write other methods. Okay. So the idea is to have lots of useful little methods in your classes that make it easier for you to write other methods in other classes. Okay. So points know how to tell how far apart they are. So that can be used by the overlap in circle to find out if two circles overlap or not. Okay. And another example of this is if you have a rectangle, you could ask if a point is inside the rectangle or not. Okay, that might be useful. Okay, so if a rectangle describes a shape in the plane and a point is either going to be inside the rectangle or out. So this is a Boolean function. They'll tell you whether that point is inside or outside the rectangle. Okay, now over here, there's a method called centered on that asks, is the circle centered on that rectangle? What that is the center of the circle. Well, I mean, actually, centered. Let's look at centered in. Centered in asks if the circle has its center inside the rectangle. Centered on asks if the circle has its center at the center of the rectangle. Okay. So centered on asks if the circle is centered at the center of the rectangle. Centered in just asks, is the circle have its center somewhere inside the rectangle? Now, the circle may not be completely contained in the rectangle. It just asks, is the center of the circle inside the boundary of the rectangle? Okay, well, that basically means, is the center of the circle, does the rectangle contain the center of the circle? Okay, so here in centered in, it points out that what you're going to do to write centered in is use the contains method from the rectangle class. Because the circle has a center, you want to know if the center's in that rectangle. And that's exactly what rectangles know how to do. Rectangles know how to tell you whether a point, in this case, the point will be the center of the circle, whether a point is contained in the rectangle. So it's one line of code. You write one line of code, but you have to think hard about what you're writing, okay? So this centered in is just one very short line of code, but you have to, what I want you to do is to think about what this is telling you and think how you're going to use the contains method that you wrote in rectangle to write the centered in method in circle. Okay, so, and that's, again, real typical of how object-oriented programming is done. Lots of short methods that use each other. You write one method and then you use that method to write other methods. And the whole goal is to keep using, is to have these things be useful so that you can make use of them. Okay. Oh, and here's another example. See, there's two versions of contains. Because I can give you the x, y coordinates and ask you, does that point with, I can say, is this x and y inside the rectangle? Is this point inside the rectangle? Now, a point just is an x and a y, and an x and a y can be thought of as a point. So these two methods are asking the same thing. These are in two different ways. One says, if I give you a point, can you tell me if the point's inside the rectangle? The other one says, if I give you the x and y coordinates, can you tell me if they're inside the rectangle or not? You don't have to write both of these. If you write one of them, you can write the other one in terms of it. Okay, see, there's a hint here. Write one of the contains method using the other one. You don't need to write all the code out for both of them. If you know how to tell if a point P is in a rectangle, you pretty much know how to tell if X and Y. This one can call this one, or this one can call that one. And I leave it up to you to decide which way we'd rather do it. But it says write one of the contains in terms of the other. Because it's just, if you know how to tell if this is inside the rectangle, you should be able to tell if this is inside the rectangle too. Okay. So and that's one of the common strategies, is if you can use something you've already written to write something new, then use the thing you've already written. Make use of what you've already written to write something new. Okay, so read this real carefully. There's lots of little hints like that point out how you can save, in this case, it's saving a couple lines of work. Instead of writing this out in detail and writing this out in detail, which will end up looking almost exactly alike, this is just saying that once you've written one of them, you can use it to write the other one. Okay? All right. So follow the steps, step 1, step 2, step 3, step 4, and make sure that you, after you write each step, then run the test program for that step and make sure you get the output from that step. Okay? All right. Now,
Now, are we just adding on to what the previous one was? Like, let's say the first step on the rectangle, we
Yeah.
put in all those methods, and then we jump to the third step, and we just add in the other methods.
Yeah, you go
Okay.
back to, when you do the third step, you're picking up where you left off after the first step.
Perfect. Okay.
So the first step adds to rectangle. Then the third step, where is it? Oh, for the third step, in the file rectangle, define the following 3 methods. So you go back to the file rectangle. And for the fourth step, you go back to the file circle. Okay. So yeah, everything you write is going to be either in the rectangle class or in the circle class. So step 1 is in rectangle, and step 3 is in rectangle, and step 2 is in circle, and step 4 is in circle. Okay.
So for us turning in the homework assignment, you just want one full rectangle .java file, and then one full circle.java file with everything in it?
Yeah, you'll have, when you're finished with step 4, you'll have finished the rectangle and you'll have finished circle.
I get it now. Perfect.
See, so by the time, actually, you'll be done with rectangle by the time you do step 3. After you've done step 3, you're done with rectangle. And then step 4, you'll finish circle. And then you'll turn in that one file. Those 2 files. You'll turn in those 2 files. Okay? You don't need to send me anything else. You don't need to send me point or dimension or any of the test programs. Just send, rectangle and circle. And I'll test your code. Okay? So you'll be done with rectangle after step 3, and you'll be done with circle after step 4. Okay? What other questions about the mechanics of this homework assignment? Any other questions? Okay. Now, okay, so, there's one last reading assignment. That's the last. We've actually talked about much of these ideas. Classes, there's a lot of ideas in talking about classes, and it's hard to do them in a linear order. So we've been talking about a lot of these things at once, okay? So, but the reading is good. The reading reviews all these ideas. We've been talking about them mostly as we wrote the point example. So far our point example has been the main example for talking about these ideas, and you're using them over here in the point class is written for you, but you're adding to circle and rectangle. Okay. So there's a lot of ideas. If you look at the review for the exam, the final exam, here's a list of the ideas. This is what you need to know about objects. We've been, these are the things that the homework assignment talks about and that we've been talking about. Instance variables, instance methods, using the dot notation, what are constructors? If you make something private, then you need access methods, okay? Scope, which we haven't used, we need to talk about this a little bit more. We've talked about the equals method versus the equal symbol. There's 2 different ways of asking if something are equal, and this idea of mutable versus immutable. So these are the words we're using. Okay, so these are the words, and if you notice at the last reading assignment, scope, instance methods, we'll talk about static methods in a minute. Static methods are nothing new. We've talked about those since the beginning of the semester. So here's just a review back of static methods. Okay, and the this keyword. I should have put that in this list. I think I'll add that. The this keyword is real important, and I forgot to put that in this list here. yeah, in this list here, I should have this keyword because it's such an important idea. So I forgot to add that to this list here. Okay, so you can see the names of these reading sections, and then the ones we've covered here: constructors, accessors, mutators. So those are the words. You know, there's a section for each. Pretty much each idea has a section. Okay, so each idea in studying classes: mutator, accessor, constructor, this, scope, instance, methods. Yeah, all those ideas have, each one has a short section in the book. Okay, but they put them in a certain order, but the truth is you really kind of learn all these ideas as a blob. It's really hard to say that this idea comes first and this idea comes second and this idea comes third. It's not that simple. The ideas are just all bundled together. So every book kind of puts them in an order, but the truth is you have to read the whole chapter and kind of put them all together. There really isn't an order to these ideas. That's just all the ideas involved in classes. No one of those ideas comes first. The only one that might come first is instance variables, the data that's in the class. A class holds data. Okay, that's maybe the main idea. Then there's all this other stuff that influences that data. So you might say that the very first idea of a class is that it holds data, and the fields, the instance variables, describe the data. Then everything else follows from that. Okay. What we're going to do today is last week we wrote a point class. This week we're going to write another class. We're going to write a class and use it to describe all these ideas. So I'll show you what I mean. I'm going to open Java Visualizer. And I want to write a class bank account. This is a real, you'll see this in book after book after book. A bank account class is a real common, like point class is real common example, and bank account class is another real common example. So let's think about what it would mean to describe a bank account. Okay, so the first thing, like we said a minute ago, the first thing is what's the data in an object. So a bank account object would, I'll start giving examples. You would have an int that is the account number. Okay, a bank account needs an account number. Okay, and then you'd have maybe a double that is the balance. That's how much money's in it. Okay, and you might have a string, the name of the person who owns it. Okay, so there's a real bare bones idea of a bank account: an account number, a balance, and then you might actually do something like string type. Yeah, is it a savings account? Is it a checking account? So I'll put string type to determine whether it's a savings account, okay, it could be savings account, checking account, etc. Okay, retirement account. Okay, all right. So there's some data. Okay, and a bank account would have this data. And actually, I actually have now a working bank account. I could go up here and say, okay, I can create a bank account object. Okay, so I can create a bank account object. And if I haven't messed up, see, it compiled. See, there's my bank account object. Okay, notice I'm in the constructor now. So line 4 sent me to the constructor to build a new account object. So I'm in the constructor and I'm building the account object. Now, the first thing you do in the constructor is the constructor is built with all default values for everything. Okay, so everything gets its default value. Okay, now I don't actually change anything, so this is just going to immediately return, and I have a bank account with nothing but default values. Okay, ints are 0, doubles are 0, and string reference variables are nulls. Those are the default value. Okay, so right now everything gets its default value, which isn't a very useful thing for a bank account. having a zero as an account number and a null for type is probably not useful. So now let's go back and let's start doing things. Like the first thing we should do is write a real constructor. Okay, so a constructor is what lets us put our idea of what the data should be into the bank account. Instead of it being full of just default values, we want to be able to say that I want to be able to say what should be the data in the bank account when it's created. Okay, so definitely I need to give it an account number. When I create an account, I should give it an account number. Okay, and what else should I? And I'm not going to give it a balance. Okay, because when I create an account, I'll leave the balance. The default value makes sense for the balance. Okay, but I will give it a string name, and I will give it a string type. Okay, so when I create the bank account, I should give it a bank account number, I should give it a name, and I should give it a type, and I'll leave the balance the way the default value, because when you create an account, it makes sense that you could start it off with 0 balance. Okay, now remember, what we do is these are parameters to the constructor. These are the fields in the object. What we want to say is this account number is set to be the parameter. What did I type here? I want to copy this parameter from the constructor into this field. Okay? And I want to do the same with the name. This is the parameter. Somebody said, here's a name for the bank account. Okay, so somebody called the constructor and said, here's a name for the bank account. So I need to move that name from that parameter to that field. Now, this is a reference variable, so I'm just copying the arrow. So this is an arrow pointing at a string, and I'm copying that arrow here. So now the bank account points to that string. And same for the type. Okay. Now I can go up here and I can create a bank account with a account number of 123 and a name of Jane and a type okay. Now I can use my constructor to construct an oops, oh, what did I forget?
You didn't put a comma after Jane.
Ah, good. Notice that that's a good. Now notice the error message. Close parentheses expected, and you click OK, and there, the close parentheses is there. But what's really missing? Remember, this is typical of error messages. Error messages only give you a hint of what's actually wrong. You have to look at your code carefully to find the actual mistake. Okay. Now what's better? Okay. Oh, I made a real dumb mistake. Did anybody see what I've done? This one's subtle. Does anybody see the mistake? It's kind of subtle. I'm missing the body of the method, but the body is this. It's there. See?
Is it because you put a semicolon at the end of the name?
Yeah, because I put the stray semicolon there that doesn't belong there. That cut away. See, that ended this thing and it cut away the body. So Java thinks that this method is missing its body. The problem was that stray semicolon. Okay, when I was typing, I just accidentally typed the stray semicolon there, and that's real easy to do. I don't know if somehow everybody makes this mistake. I do it all the time, and notice that the error message is kind of subtle. It does not tell you you have a stray semicolon. It tells you that you're missing the body. Okay, so get rid of that semicolon. Okay, now create a bank account object. Notice that when I enter the constructor, everything gets its default value. So the constructor has built this object. Here's the parameter values. Now we want to copy that parameter value into there. We want to copy an arrow. Oh, let me go back and set to set the visualizer to do strings the right way. Show strings the right way. Okay, so see, name points to that string and type points to that string. I want this name to point to that string. I want this type to point to that string. And I want to copy this account number. I want to copy this account number into account number. Okay, so now I'm going to start copying things. So there's the account number copied from there to the object. There's that arrow got copied to there. So now the object points to Jane as its name. Then that arrow got copied to there. So now the bank account says savings account. Now I'm done. I'm going to return. And there's my account with the account number, balance of 0, and a name and a savings. Okay. All right. So now I've got accounts. Now let me give another constructor. I said here that this constructor would let the bank account have the default value for this balance. What I'm going to do is I'm going to say, but I also think there ought to be another constructor that lets you create an account with an initial balance. So now let's do this one with a double. Okay, so now I've got a second constructor that lets somebody say, but this when I create the account, I want this to be the initial balance. Okay, so I'll do that here. But here's something that's interesting. Okay, here's what's not good enough. This dot balance equals balance. Okay, here's what's wrong with that. Okay, now so far this is okay, but I'm not using that constructor. So let me go back and let me create a bank account 2. Equals new bank account. This will be account 456. The balance will be -$10. And this account belongs to Bob. And it's going to be a checking account. Okay, now what's wrong with this? What's not so great here?
So the balance is negative?
Yeah, I mean, bank accounts can have negative balances. But what's weird about this? How do you get, you get a negative balance by overdrawing your account. That's one way to get a negative balance. Can you get a negative balance by going into a bank and say, hey, create me an account and put -$20 in there?
No.
No, you can't create an account with a negative balance. So this shouldn't make sense. So here's what I'm going to do. I'm going to go down here, and before I do this, I'm going to put an if statement. It says if balance is less than 0. Now this is part of what object-oriented programming is really about. We want to write things so that we check things. If the balance is less than 0, I really want to somehow report that there's an error. Else, then it's okay to do this. So I want my constructor to say, but I should double check that these numbers make sense. You shouldn't be creating an account with a negative balance. Now, now there's some kind of problem here. If the balance is negative, there's a problem. There's a lot of ways of reporting problems. Here's what you'll learn about. I'm just going to type this. You throw an exception. This is a way of a lot. This is a Java way of a program saying there's a problem. I give an error message. So this is a way of reporting an error message. Throw new exception. What it does is it halts the program. Okay, so let's try this. Let's see what happens. Oh. What? Oh, yeah, what Java's making me do here is I have to add here. I wanted let's see. I'm trying to remember now. I want to. I don't want to. I want to change it. What do I? Let's not throw an exception. What we'll just do is this is the other way of a program. This is just halting the program. Oh, now their website screwed up. Let me save this. Let me save this just in case so it looks like their website kind of screwed up. Huh. Oh, I think I know what's going wrong. I don't think they like me putting this line of code in there. Yeah, I think I don't think the Java visualizer likes this line of code here. Ah. See, this is one of the things we want. This is where this next course is going to pick up. Things like, what do we do when something goes wrong in our code? We detect that there's something wrong. Here, I'm just trying to end the program, but the Java visualizer doesn't even let me end the program. The Java visualizer doesn't like this. This is a way of just saying end the program. Okay, the better way is to throw an exception. I'll go back to that. Okay. Trouble is that this makes me type a little bit more extra code.
You spelled exception wrong.
Oh. Okay, now finally, so we create an account, we create one bank account, okay. Okay, now we're gonna create this other bank account and watch what happens. Okay, here's the blank account, starts off with default values. Now we go in and put the account number in there, the name, and now we're gonna check the balance. But the balance is a negative number, which is bad. We shouldn't be creating an account with a negative number. So this if statement's going to turn out to be true. And now we're going to throw the exception. And what that does is it halts the program. Okay. Now, here's why this is useful. Okay. Watch what I could do. Okay. I'm going to create the account with $10 in it, and then I'm going to say the balance is negative 1 million. Okay. Create the account, create the second account. Okay, here's the two accounts. This one's got a balance of 10. Okay, this is account 2. Now let's look at this line of code. It goes in there and just updates the balance to be negative 1 million or one, yeah, okay. You shouldn't be able to just reach into a bank account and make a change in its balance. Okay, that's a really bad thing to be able to do. No code should be able to just reach inside of an object and change things. What we need to do is go back here. These should all be private. Notice I didn't put the word private or public in front of them. Right now, they actually are public fields. Anyone could reach into them. They should be private. Now, that means that we control, by making these private, our code controls what can be in, for example, the balance. See, now it makes sense that we check that the balance is negative, because if we're not going to allow a negative balance, we shouldn't be allowed somebody to do this. See, it didn't really make sense that we stopped there being a negative balance here, but we let anybody change the balance here. Now, there's not going to be any way to change the balance after you create the account. So this won't even compile now. See, now this won't compile because balance has private access in bank account. You can no longer just reach in and change the balance. But if we can't, but then how do you change the balance? Well, normally you change a balance by making a deposit. So let's write a deposit method. See, so now we want to write what we call the mutator methods. We want to be able to say, I want to be able to deposit money in an account. So I would say public deposit. Here's a method that deposits a double amount. So I'm going to deposit that amount into the bank account. Okay. Now, what that does is it's like the move methods in points. It's just going to take a balance and plus equal the amount. Okay. But now there's something else I should check. Oh, and then this doesn't return a value because it mutates the balance. Okay, it mutates the balance. It doesn't return anything. It makes a change to the balance. Okay, but what should I check here? What would make sense? That what's a bad thing to happen here? I got a similar problem I had in the constructor. What should be true about amount? When you go to deposit money in your account, what's true about that number?
It can't be negative.
Yeah, you shouldn't allow people to deposit negative numbers. Now, notice that double, see, here's double can be negative. There's nothing in Java that stops double from being negative. but it doesn't make sense to deposit a negative number. So what I'm going to do is I'm going to do an if statement just like I did up here. I'm going to go down here and make this an if statement, and it's going to be if the amount of the deposit is less than 0, cannot deposit negative amount, else this dot balance plus equals amount. Notice that I'm using logic to make sure that the values in the account stay reasonable, for one thing. Okay, so you can't deposit a negative number amount in a bank account. Okay, so this, if somebody tries to deposit a negative number, this thing will stop the program from working. So this is a way of saying, I want the program to not continue on, because it doesn't make sense that somebody deposited a negative number. If the amount they're depositing is a positive number, go ahead and add it to the amount. Okay. Now, besides depositing, what else should you be able to do? Withdrawing. So let's copy and paste this and make it a withdrawal method. Okay. All right. Now withdrawal is going to be a little bit even trickier. So I'm going to write this withdrawal. Okay, withdraw an amount. Now, can I withdraw? Now, withdrawing by definition means that you're subtracting that amount. So the amount should not be negative. Okay, cannot withdraw negative amount. Okay, so notice that you're withdrawing a positive number, but what you're going to do is subtract it from the balance. Okay, so when you do a withdrawal, you subtract it. All right, so this should still be a positive number. It makes no sense to withdraw a negative number. What makes it a withdrawal is I subtract it from the amount. But now I have to worry about something else. What is that?
You can't withdraw more than what you have.
Yeah, so I need another if statement here. If what?
Withdraw is greater than balance.
Well, actually, I've already done the withdrawal. What would be a better thing for me to check at this point?
If balance is less than 0.
Yeah, if the see, I've gone ahead and done the withdrawal. I've done the withdrawal, so now I'm going to say if this dot balance is gone negative, then I'm going to throw another exception. I need to let someone know that there's something gone wrong. So I'm going to throw exception. Okay. All right. So this is part of what we think of in object-oriented programming, is that we keep checking that things are making sense. Now, because we've made these things private, none of this would make sense if these things weren't private. If these things weren't private, anybody could stick anything they wanted into that balance field. You know, if it wasn't for the fact that that was private, remember, you could just go up here and go account to dot balance equal anything you want. Okay, we don't want to allow that. Okay, we don't want to allow you to put anything. So we make this balance private. Okay, and then this code can't, you can't just shove anything in there. Then once we've made this thing private, then we can protect it. We can make sure that that nobody deposits negative numbers. Nobody creates that. If an account goes negative, there's an error message to say that the account has gone negative. Okay, now here's another thing. What about account number? Should you be allowed to change the account number in a bank account?
No.
Probably not. What we'll do is this thing is going to be immutable. There isn't going to be a method to update the account number. Once the bank account is created, there'll be nothing in here that lets you change the account number. And it's private, so that means there's really no, once you create an account, you will not be able to change the account number. Okay. Now, balance, of course, has to be mutable. And that is with the deposit method and withdraw. The withdraw and deposit methods let you change the balance. Okay. What about type? You can go back and forth about that. I would say that that should be immutable. That if you created a checking account, it stays a checking account. If you want to make it into a, most banks actually make you close one account and reopen another one. So let's make this thing immutable. That means that we don't provide any method that would change the type. Now, what about name? Mutable or immutable?
Mutable.
Probably, people do change their name, and they should be allowed to change their name if somebody wants to change their name, they should be able to go to the bank and just have their name updated. So we'll make this mutable, but then we have to provide a change name method. So we'll have to go down here now and write a net method for we have to write a change name method, which will take in a string, which is the new name. Okay. And we'll just do this dot name equals name. Now, if this was a real bank account, we might put here's what would be interesting though. We could put code here to in a real bank account, there'd be something here that verified that you had the authority to change the name. So something might ask a user to log in or provide a password. Okay, so even here, we don't have a real mechanism for doing this, but in a real bank account, see, you would verify, you would have code here, just like here we had code that checked that you weren't doing something wrong, like depositing a negative number, that you weren't doing something wrong, like withdrawing a negative number. Here, you could have code that would verify that somebody has the authority to change a name. Okay, so I'll just write that as a comment, but that's, see, because this thing is a private here, our code controls, because this is private, our code controls what's in that field. So if we want to allow someone to change it, so we provide a change name method, but we could still put a logic in there that says things like, well, but you have to prove that you have the authority to change the name. You have to provide a password or a PIN number or something. Okay, so there would be logic in here that would make sure that the person had the right to change the name. Okay, so notice that we make a lot of use of this private. It's almost always the case that when you have objects, you keep the fields private so that you can control the access to them. And then you can have your methods control access. Now, here I'm throwing an error. I'm throwing an exception when something is wrong. That's just, in the next semester, you'll see how you really make use of this. But this is actually a really good feature of Java. When Java code thinks that there's something not happening correctly, Java code can throw what's called an exception. Here, we just want to point out that what this deposit should do is protect this balance. It should not let you deposit negative numbers. It should not let you withdraw negative numbers. If you withdraw and the balance goes negative, somebody should be aware of that, so you should throw this exception. So that makes someone aware. Oh, notice that this uses the word throw. The reason they use the word throw is because it turns out you can also catch exceptions. And catching them is how you can correct the mistake. So throwing an exception doesn't really have to crash a program. A program can be written to catch exceptions, and that provides a mechanism for fixing errors. So this code would throw an error, and some other code would possibly catch that error and handle, oh, this is what we do when a balance goes negative. We put a little bit extra money in the account, charge it a fee, send a letter to the owner, blah, blah, blah. So the throw right now crashes the program, but later you'll learn how you can catch the exception. And when you catch it, you could fix the error. You could do something that fixes the error. Okay, so this is kind of the idea of how object-oriented programming is really used. You create accounts, you create objects with fields, you make the fields private, and then you think about what should and shouldn't be allowed to be in those fields. What kind of methods do you want to give people? In our case, you want to be able to deposit and withdraw, and you want to be able to change the name. We do not want to be able to change the account number. Once a bank account's created, the account number should never change. The balance should only change by doing deposits and withdrawals. Okay, and the name should only change by calling change name, which, if we want to, can control who's allowed to change it. And we're not going to allow you to change the type of an account. Yeah, if you created a checking account, you would have to close it to be able to convert it to another kind of account. So we have some immutable and some mutable fields, and they're immutable by we not providing any we make it private, and we don't provide any method that changes that field. So by making it private and having no method that changes it, it becomes immutable. Making it private and giving you accessor methods lets you make it mutable. Okay, so that's an example of how we think about object-oriented programming. We write these, we design a class with the data we think it belongs in it, and then we would create constructors. Here, notice I gave two constructors. One that just used the default balance and one that lets you choose a balance. But once you choose a balance, you have to be careful that it doesn't initially be a negative balance. So I think about what would be convenient. Now, notice I didn't have to have this constructor. I could have said that the way you create an account is always with 0, and then you have to do a deposit. So I could have not had, it was my choice to have this constructor. I don't have to have it. Otherwise, if I didn't have this constructor, you'd construct a bank account with a default balance of 0, and then you'd have to immediately do a deposit into it to give it its initial balance. And so, and then as the person writing the code, I get to decide whether I think this is a good idea or not. Do I think that constructor belongs there? Yeah, I think it does, so I put it there. My boss might say, no, we don't want that constructor there, so you have to remove it. And you want just this constructor that has the default value of balance. As the designer of the class, you get to choose these things. Okay, so that's another example of designing a class. Your homework assignment is you're designing, or you're writing the implementation of two classes, circle and rectangle. Okay, and on Wednesday, we'll look at if you have questions about the homework or questions about the review problems. Okay, so on Wednesday's class, we can look at the homework assignment and also these new review problems. Okay, so we'll quit there. We've run over time, so we'll quit there. So Wednesday will be Wednesday's the last class. The final exam's a week from today, and on Wednesday we'll go over any questions about what we've been talking about with these classes and objects. Okay, so I'll go ahead and stop sharing. See you on Wednesday. If you have questions about the review, and you can start asking questions about the review problems. If you have questions about the review problems, you can send them to me anytime. So see you on Wednesday. Goodbye.